All right, guys, so our next lesson with statistics is going to be about standard deviation. Standard deviation, I'm sure you've heard it before, but you may not actually know what it actually is yet. So the definition for standard deviation is a number used to tell how measurements for a group are spread out from the mean. A number used to tell how measurements for a group are spread out from the mean. So this actually, especially like with what's going on in the news right now, you're going to see a lot of what's called bell curves. But if you have a curve, right, and this here is the mean, x bar, right? We did that yesterday. If you have a small standard deviation, right, let's say your standard deviation's 2. Let's say that the mean for something is 70. So let's say the average for a test is 70. If your standard deviation is 2, that means the range of one standard deviation away from the mean is between 68 and 72. It's all kind of close together. The larger your standard deviation, let's say your standard deviation is 10, then you would go from 60 to 80. The larger that your standard deviation is, the more spread out that your data is. Okay, that might sound a little confusing. It'll definitely make more sense when I show you a normal curve in the next video. But what I just said is also explained right here. A low standard deviation indicates that the data points tend to be very close to the mean. So if it's a small standard deviation, most of your data is close to the mean, whereas if you have a high standard deviation, the data is more spread out. It's a larger range. The min and the max are farther away from the average or the mean. Okay, so you could have a normal or a skewed standard deviation. So if you look at this chart, right, not all data is going to be perfect. You don't always see this normal curve in the middle, right? That's what we want. This is called a normal curve. You might have heard of it as a bell curve, right? So a normal curve, there's no skew. So it's not, the data isn't being skewed anywhere to the left or to the right. You have probably heard the word skew before, right? If you have some students in your class do like really, really well, that skews your data because those grades are bringing the average up. So that's skewing your data. So if it's a normal curve, then there's no skew. When that happens, the mean is the same thing as the median, is the same thing as the mode. Okay, so those three numbers are all the same. So if your mean is 70, then the median is 70, and then the mode is 70. That's not always the case. This is going to be our main priority when we're talking about statistics, but that's not always really going to be the case. That's like in a perfect world, you see normal distributions. If you have skews, you could have a negative skew or a positive skew. A negative skew, it has a little bit of a tail. We call this a tail. This is tailed to the left. The tail goes off to the left. If it's a tail to the left, it's a negative skew, which is what we have up here. A negative skew is tailed to the left. So whenever your data is skewed, the mean is going to go towards the tail. So because this is tailed to the left, the mean moves left. You can think of this bottom as a number line. So the mean is the smallest number. For example, if your mode is 70, again, think of the bottom as a number line, then your median could be, say, 65, and then your mean could be, say, 50 on this example. So the mean is less than the median. Median's always in the middle. And then that's less than the mode. Okay, that's different from our normal scale. Remember, our normal scale, the mean, the median, and the mode are all the same thing. However, if it's negatively skewed, the mean is the smallest number out of those three. And then the median is in the middle, and then the mode would be the largest out of the three. Likewise, if we're talking about positive skew, a positive skew, it's tailed to the right. It's tailed to the right. So meaning that this comes up and then it dies off a little bit. It's skewed to the right. It's tailed to the right. So again, the mean goes with the tail. So now your mean is on the right side, meaning that it's larger than the mode or the median. So in this case, the mode is the smallest number. So the mode is smaller than the median, which is always going to be in the middle, which is smaller than the mean. Okay, so for example, in this one, if your mode, let's say your mode is 10, then your median may be 12, and your mean may be 15. Again, the bottom is just like a normal x-axis type thing. It's like a number line. Okay, so that's skewed in a positive direction. Okay, so an example of something that you could be asked. Down here we have a histogram, shows the distribution of the amount of time it takes students to complete one multiple choice question on a history exam at Center Reach. So as you can see, this is your curve, right? So this says, would this distribution of multiple choice completion time be best described as normal or skewed? If you look, this goes off to the right a little bit. So this answer, this is going to be skewed, and it's going to be positively skewed. And it says to explain. So it's skewed positively because it is asymmetrical, right? It's not symmetrical, and is tailed to the right. Okay? You don't have to say it's positively skewed. It doesn't ask you that. And you don't have to say it's tailed to the right either. You could just say it's skewed because it's asymmetrical, or you could say it's skewed because it has a tail to the right. Either way, it's fine. Is the mean of the time per multiple choice question closer to 100, 150, or 200 seconds? So if we label these three things, 100 is right here, 150 is right here, and 200 is over here. So if you remember, this is the mode right here. The mode is the most, the mode is the highest. The median is in the middle, and then the mean goes with the tail. The mean it follows the tail. So if this is tail to the right, so the mean would be your rightmost option. So your best option for this would be 200 seconds. Okay? All right. So make sure you take your notes on this. You submit them in to me tonight by midnight. And then tomorrow, be on the lookout for your homework worksheet. Have a great day, guys.